Imagine a planet so far away that sunlight, traveling at 670 million miles per hour, takes over 4 hours just to reach its surface. A world so distant, so cold, and so mysterious that, for most of human history, we didn't even know it existed. And until just a few decades ago, nobody had ever truly seen it up close. Not its storms, not its rings, not its strange, icy moon that orbits backward. That planet is Neptune, the 8th planet from the Sun and the outermost world in our entire solar system. It's a place so remote that a single spacecraft has only ever visited it once in all of human history, and that was decades ago. But something just happened that has scientists absolutely stunned. The James Webb Space Telescope has captured the clearest, sharpest, most detailed images of Neptune ever recorded by humanity. And what it revealed is something nobody expected. Rings that shouldn't be visible, storms that appear and vanish without warning, a color that turns out to be completely wrong. Even scientists who have spent their entire careers studying this planet from a distance openly admitted they were genuinely caught off guard by what these brand new images actually showed them. So what exactly did James Webb find hiding in the darkness of the outer solar system? Stay with me right until the very end, because by the end of this video, you'll never look at Neptune the same way ever again. Today, you'll discover how a planet 4.5 billion kilometers away was finally photographed in stunning detail, why scientists were shocked by what Webb's infrared cameras revealed, and the true story of how Neptune was even discovered in the first place. We'll also uncover the strange truth about its color, its violent winds, and a moon that scientists believe is a captured alien world. We'll travel back to the 1800s to see how a planet was found using nothing but a pencil and paper, and we'll fast forward to the present day to see exactly what Webb's cameras picked up that no telescope had ever captured before. Stay until the end, because I'm going to show you the one prediction about Neptune's future that sounds more like science fiction than science fact. If you love exploring the mysteries of space, hit subscribe, because we're just getting started and this is only the beginning of what Neptune has been hiding. Let's start with the basics. Neptune sits at an average distance of about 4.5 billion kilometers from the Sun. That's roughly 30 times farther from the Sun than Earth is. If you tried to drive there nonstop at highway speed, it would take you approximately 5,000 years to arrive. Even the fastest spacecraft ever launched by humanity would still need over a decade of continuous travel just to reach it. In terms of size, Neptune is massive. Its diameter measures about 49,000 kilometers, which makes it nearly 4 times wider than Earth. In fact, if Neptune were a hollow ball, you could fit almost 58 Earths inside it, and there would still be room left over. Scientifically, Neptune is classified as an ice giant, a category it shares with its neighbor Uranus. Unlike Jupiter and Saturn, which are made mostly of hydrogen and helium gas, ice giants contain a thick layer of water, ammonia, and methane ices, surrounding a small rocky core. This is a key distinction that separates Neptune from the 2 larger gas giants closer to the Sun. Neptune's atmosphere blends smoothly into this icy mantle, meaning there's no solid surface anywhere on the planet for a spacecraft to actually land on. Compared to Earth, Neptune is a world of extremes. Where Earth has gentle breezes, Neptune has supersonic winds. Where Earth takes 1 year to orbit the Sun, Neptune takes 165 Earth years to complete a single orbit. That means since its discovery in 1846, Neptune has only completed 1 full trip around the Sun. Let that sink in for a moment. Nobody alive today has witnessed Neptune complete even 1 full year. Every single person who has ever lived has only ever seen a small fraction of Neptune's incredibly slow journey around our star. Neptune also has 14 known moons, an average surface temperature hovering around negative 200 degrees Celsius, and a day that lasts just over 16 hours, meaning that despite being so far from the Sun, Neptune actually spins faster than Earth does. Numbers alone don't mean much until you actually visualize them. So let's break this down in a way that truly captures how extreme Neptune really is. We already said Neptune is 4.5 billion kilometers from the Sun, but here's what that actually means. If you shrank the Sun down to the size of a basketball placed in New York City, Earth would be a small marble sitting about 24 meters away. Neptune, on that same scale, would be a tiny pea rolling nearly 700 meters down the street, almost 7 football fields away. Now think about sunlight. On Earth, sunlight takes about 8 minutes to arrive. On Neptune, that same light takes over 4 hours. If you sent a text message to someone standing on Neptune traveling at the speed of light, you would wait more than 8 hours just to get a simple reply. Then there's the wind. Neptune has recorded wind speeds reaching up to 2,100 kilometers per hour. To put that into perspective, the strongest hurricane ever recorded on Earth topped out at around 345 kilometers per hour. Neptune's winds are more than 6 times stronger than the most violent storm our planet has ever produced. And here's something even stranger. Despite being 17 times more massive than Earth, Neptune's surface gravity is only slightly stronger than our own. If you weighed 100 pounds on Earth, you would weigh about 114 pounds on Neptune, Not crushing, just slightly heavier, even though the planet itself is a giant. This happens because Neptune's lower density spreads its mass across a much larger volume, which balances out the extra gravitational pull you might expect from a planet so much bigger than Earth. It's a perfect example of how size and gravity don't always scale together the way our intuition might suggest. And it's one of the small, quiet details that reminds us how much our assumptions about giant planets can be wrong until we actually study the numbers. These comparisons are exactly why Neptune fascinates scientists so much. It's a world of contradictions, distant yet familiar, massive yet gentle, calm on the surface, yet violently chaotic underneath. And that's exactly the kind of contradiction that keeps astronomers coming back to study this planet again and again, even with such limited data available to them. Neptune's discovery is one of the greatest detective stories in the history of astronomy. It actually begins with Galileo Galilei back in 1613. While observing Jupiter through his telescope, Galileo noticed a faint blue dot near the planet. He assumed it was simply a distant star and moved on. Centuries later, astronomers realized that faint dot was actually Neptune itself, meaning Galileo had unknowingly spotted the planet more than 200 years before it was officially discovered. The real breakthrough came in the early 1800s, when astronomers studying Uranus noticed something strange. Uranus wasn't following the orbital path predicted by Newton's laws of gravity. Something invisible seemed to be tugging on it, pulling it slightly off course. At first, astronomers assumed there must be an error somewhere in their calculations or observations, since Newton's laws had accurately predicted planetary motion for over a century without fail. Rather than dismissing this as an error, mathematicians took it as a challenge. Using nothing but pure mathematics, French astronomer Urbain Le Verrier calculated exactly where an unseen planet must be hiding in order to cause these gravitational disturbances. He sent his predictions to the Berlin Observatory, and on the night of September 23, 1846, astronomer Johann Galle pointed his telescope to the exact coordinates Le Verrier had calculated. Within less than an hour, he found it. A planet, almost exactly where the math said it would be. Neptune became the first planet in history to be discovered through mathematical prediction rather than direct observation. It wasn't found by accident. It was found because someone trusted the numbers. That moment marked one of the greatest triumphs of theoretical science, proving that the universe follows precise, predictable laws, even in places humans had never seen. Interestingly, a British astronomer named John Couch Adams had performed very similar calculations around the same time, leading to a long-standing dispute over who truly deserves credit for the discovery, a debate that historians of science still discuss to this day. Either way, Neptune's discovery remains one of the purest examples of mathematics revealing something real about our universe before human eyes ever confirmed it. It's worth remembering that this all happened using nothing but pen, paper, and an intimate understanding of gravity. Decades before computers, decades before space telescopes, and more than a century before humanity ever launched a single spacecraft toward the outer solar system. Now, let's go deeper into what actually makes Neptune such a strange and beautiful world, moving beyond the basic numbers and into the science that explains why this planet behaves the way it does. First, its color. For decades, Neptune was believed to be a deep, vivid blue, largely thanks to early images from Voyager 2, but newer analysis has revealed something surprising. Neptune's true color is actually a much paler, more muted blue-green, closer in appearance to Uranus than previously thought. So why does this happen? The intense blue color we associate with Neptune comes from methane gas in its atmosphere. Methane absorbs red light and reflects blue light back into space, giving the planet its signature icy blue glow. However, older image processing techniques exaggerated the saturation, making Neptune appear far more vividly blue than it truly is in reality. When researchers reprocessed the original Voyager 2 data using modern calibration methods, they found that Neptune's actual color is remarkably close to that of Uranus, a soft, pale cyan rather than the deep sapphire blue most people picture when they imagine this planet. Next, let's talk about the atmosphere itself. Neptune's atmosphere is composed mostly of hydrogen and helium, making up the bulk of the outer layers, with that crucial layer of methane, roughly 1 to 2% of the total composition, responsible for its color. Beneath the visible atmosphere lies a dense layer of water, ammonia, and methane ices, which is why Neptune is classified as an ice giant rather than a gas giant. So why does Neptune have such violent winds? Scientists believe it comes down to internal heat. Despite being the farthest planet from the sun, Neptune radiates about 2.6 times more heat than it receives from sunlight. Nobody fully understands where this extra heat comes from, but it's believed to be left over from the planet's formation, slowly leaking out from its core. This internal heat creates massive temperature differences within the atmosphere, and those temperature differences are what drive Neptune's supersonic winds, the fastest planetary winds ever recorded in our entire solar system. So essentially, Neptune is a planet powered from the inside out. A cold, distant world with a mysterious internal engine that scientists are still trying to fully understand. Interestingly, Uranus, despite being very similar in size and composition to Neptune, does not radiate nearly as much internal heat, and nobody knows exactly why these two seemingly twin planets behave so differently. Some scientists believe it may be connected to a massive ancient collision, similar to the impact theory used to explain Uranus's extreme sideways tilt, but this remains an open question in planetary science. What we do know is that the combination of extreme cold at the cloud tops and intense heat deep within the planet creates a powerful convection engine, constantly pushing warm gas upward and cold gas downward, and it's this churning motion that helps generate the ferocious winds racing around Neptune's atmosphere. Now here's the moment you've been waiting for, the part of Neptune's story where science fiction quietly turned into science fact. For over a century after its discovery, Neptune remained nothing more than a blurry dot, even through the most powerful telescopes on Earth. That changed in August 1989, when NASA's Voyager 2 spacecraft became the first and, to this day, its only spacecraft to fly past Neptune. During that historic flyby, Voyager 2 captured humanity's first real detailed images of the planet, revealing a world far more dynamic than anyone had imagined. Among its discoveries was a massive dark storm system nicknamed the Great Dark Spot, a swirling anticyclone roughly the size of Earth itself. It was reminiscent of Jupiter's famous Great Red Spot, except Neptune's storm behaved very differently. Just a few years later, when the Hubble Space Telescope looked back at Neptune, the Great Dark Spot had completely vanished, only for a new dark storm to appear in a different location. This taught scientists something crucial. Neptune's atmosphere is incredibly dynamic, constantly forming and dissolving massive storm systems in ways we still don't fully understand. Now, decades later, the James Webb Space Telescope has taken this exploration even further. Using its powerful infrared instruments, Webb captured the clearest, most detailed images of Neptune ever recorded, revealing its delicate ring system glowing with striking clarity, something so faint it had barely been visible since the Voyager 2 flyby. Webb's images also revealed bright, high-altitude storm features and a strange glowing haze near Neptune's poles caused by seasonal atmospheric changes. For astronomers, this wasn't just a beautiful photograph, it was a scientific breakthrough, giving humanity our best look yet at a planet that remains almost entirely unexplored, all from over 4 billion kilometers away. What makes this even more remarkable is that Webb captured these details without ever leaving the vicinity of Earth. It observes Neptune from roughly 1.5 million kilometers away, orbiting a stable point in space, and yet it can resolve details on a planet billions of kilometers farther out with a clarity that rivals spacecraft flybys. That alone tells you just how far telescope technology has advanced since Voyager 2's historic encounter. Neptune's story doesn't end with the planet itself. Around it exists an entire system of fascinating interconnected mysteries, each one worthy of its own documentary. Let's start with its rings. Yes, Neptune has rings, though they're incredibly faint and dusty compared to Saturn's famous, bright, icy bands. Discovered in 1989, Neptune's ring system is made up of narrow, clumped bands of icy particles, so dim that they went completely undetected until Voyager 2's flyby. Recent images from James Webb have shown these rings in unprecedented detail, appearing as delicate glowing threads circling the planet. Then there's Triton, Neptune's largest moon, and quite possibly one of the strangest objects in our entire solar system. Unlike almost every other large moon, Triton orbits Neptune backward, moving in the opposite direction of the planet's rotation. This retrograde orbit is a massive clue, and most scientists believe Triton wasn't originally born alongside Neptune at all. Instead, it's believed to be a captured object, likely a dwarf planet similar to Pluto, that wandered too close to Neptune's gravity, and became permanently trapped in orbit. Triton isn't just strange in its movement either. It's geologically active, featuring nitrogen ice volcanoes that erupt not lava, but freezing geysers of nitrogen gas and dark, icy particles, shooting plumes up to 8 kilometers into its thin atmosphere. This makes Triton one of the very few moons in our solar system with confirmed active geological activity, placing it in the same rare category as Jupiter's moon Io and Saturn's moon Enceladus. Its surface temperature hovers around negative 235 degrees Celsius, making it one of the coldest known objects ever measured in our solar system. And yet, somehow, it still manages to erupt. Beyond Triton, Neptune has 13 other known moons, most of them small, irregular, and poorly understood, discovered gradually over the decades using increasingly powerful ground-based telescopes and, more recently, Webb itself. Some of these outer moons take well over 25 Earth years just to complete a single orbit around Neptune, drifting so far out that they barely feel the planet's gravitational pull at all. But perhaps the most jaw-dropping fact of all involves Triton's ultimate fate. Because of its backward orbit, Triton is slowly spiraling inward toward Neptune, losing altitude with every single orbit. Scientists predict that in roughly 3 to 4 billion years, Triton will eventually be torn apart by Neptune's gravity, potentially forming a spectacular new ring system, one that could make Saturn's rings look small by comparison. It's a strange thought that one of Neptune's most fascinating companions is, in a very real sense, living on borrowed time, slowly spiraling toward its own destruction while we watch from billions of kilometers away. Even with everything we now know and everything Webb has just shown us, Neptune remains one of the least explored planets in our entire solar system. No spacecraft has visited it since that single Voyager 2 flyby back in 1989, meaning almost everything we know comes from a handful of images and decades of study from telescopes millions of kilometers away. NASA and other space agencies have proposed dedicated Neptune orbiter missions designed to study the planet's atmosphere, rings, and its mysterious moon Triton up close for the very first time. However, due to the sheer distance involved, any such mission would take well over a decade just to arrive. Scientists still don't fully understand why Neptune radiates so much extra internal heat. They still don't know exactly what triggers its massive, unpredictable dark storms, or why they appear and disappear seemingly at random. And they still aren't entirely certain what lies beneath Neptune's icy outer layers, whether there's a genuine liquid ocean of water, ammonia, and methane deep within the planet, or something even stranger that we haven't yet imagined. Every new image from the James Webb Space Telescope adds another piece to this puzzle, but for every question it answers, new ones seem to appear right behind it. Some researchers hope that a dedicated Neptune mission could launch within the next decade, potentially arriving sometime in the 2040s, finally giving humanity its first real look at this planet since Voyager 2 sailed past it in the 20th century. Proposed concepts include an orbiter capable of studying Neptune's atmosphere for years at a time, along with a probe that could dive directly into the clouds, and possibly even a small lander designed to study Triton's icy, volcanic surface up close for the very first time in human history. When Voyager 2 sailed past Neptune in 1989, it captured a handful of images and then continued onward, drifting silently into interstellar space, carrying humanity's only close-up glimpse of this distant world, a farewell photograph taken as it looked back one last time before disappearing into the dark. But Voyager didn't finish Neptune's story, it only opened the first page. Decades later, James Webb picked up where Voyager left off, peering across billions of kilometers of freezing darkness to reveal details we never thought we'd see: rings, storms, and a color we thought we understood but never truly did. Neptune sits out there right now, spinning quietly at the edge of our solar system, still holding on to secrets no human has ever witnessed firsthand. And somewhere, decades or centuries from now, another telescope, another spacecraft, or perhaps another generation of scientists will look toward Neptune again and uncover the next page of a story that began with a single mathematical prediction back in 1846. Until then, all we can do is keep watching, keep wondering, and keep listening carefully for whatever quiet secret Neptune decides to reveal to us next, one distant photograph at a time. So here's my question for you. Which fact about Neptune surprised you the most? Was it the discovery through pure mathematics, Triton's strange backward orbit, the possibility of a hidden ocean deep beneath the clouds, or the storms that appear and vanish without warning? Let me know in the comments down below. I read every single one, and I'd genuinely love to know exactly which part of this whole incredible story stuck with you the most. If you enjoyed this journey through the outer solar system, make sure to subscribe and hit the notification bell because there are still so many more mysteries out there waiting to be uncovered, from the icy moons of Jupiter to the storms of Saturn and everything in between. Thanks so much for watching, and I will see you in the very next one.